packing efficiency in the solid state, molecular polarity, and intermolecular interactions differ with stereochemistry, causing differences in melting and boiling points between stereoisomers. Imagine two toys that are the same shape, but one has a sticker on the left and the other has the sticker on the right. They are like stereoisomers. When molecules pack into a solid, how snugly they fit changes with that left or right arrangement. So one may form a tighter, more ordered crystal that needs more heat to break apart. Also, if the arrangement makes one side of the molecule a little more positive or negative, it can stick to neighbors more strongly through dipole forces or hydrogen bonds, and that also raises melting or boiling temperatures. For liquids, how molecules slide past each other depends on these same forces, so differences in shape and polarity change how much energy is needed to separate them. A common mistake is assuming identical molecular formulas always give identical physical properties, and the tip is to remember that three-dimensional arrangement matters for packing and interactions. Another error is thinking only size matters, when polarity and specific interactions like hydrogen bonding can dominate. So check for functional groups and possible orientations. Some students overlook crystal symmetry effects, and the remedy is to consider how molecules stack in the solid, rather than just drawing a flat picture. For more videos and resources on this topic, visit www.gumballdegree.com.